You're listening to The Interactome, a podcast by a group of young researchers who want to connect you to the world of science by sharing their stories and perspectives. Just in case their bosses are listening, they want to remind you that the opinions expressed here are their own. They also want to remind you not to take anything they say as medical or professional advice, as they are not doctors. Not yet, anyway. Stay tuned about that. And, without further ado, welcome to the Interactome.
Hello, Interactome listeners. We're back. Long time no see. This is Maia, and this is the first time I get to introduce myself as a newly minted PhD in molecular and cell biology. Yay!
Dr.
So, bit
Maia.
of a life update from me.
That's very
Thank
exciting.
you.
Do we have to change our intro now?
What?
Yeah, because now the intro says, they're not doctors yet, but stay tuned on that. But now one of us is a
Surprise.
doctor. So.
Not a medical doctor.
Surprise!
It's
Not a
true.
medical
It's true.
doctor, so
It's true. But
This is
don't
still
ask
not
me
professional
anything.
advice.
I could call you doctor though.
I guess unless our guest wants to give professional advice on his field of study, which I don't think he does. But he could. He could. I don't think there's any safety concerns about this particular episode.
He has all the vice he needs. But anyway, my name is Maia. I'm a new PhD grad in molecular and cell biology, and you haven't heard from me in a while because I was busy writing my dissertation and trying not to die. But today's episode is one we've been quite excited about for a really long time, and it's about science-inspired music. But before we get into it, I'll let our other hosts introduce themselves.
Hey everyone, I'm Joe. I'm MD PhD student. Been working with the Interactome podcast since it got off the ground. I actually think we have the 3 initial members here today, which is very exciting. So that's a big deal. So for context, for any listeners who are tuning in, new listeners, the 3 of us were kind of the ones who sort of got this off the ground back in 2021, I think.
Something like that.
Yeah, it's been a while. So yeah,
It's been a minute.
Yeah, but enough about me. Let's hear about our other host.
Hi, I'm Sam. I got a degree in biochemistry. I don't know what I am right now.
You are extraordinary. That's what you are.
Thank you. I am also, I guess, the person who texted Maya and showed to make the Interactive a gajillion years ago. So I guess in that way, I'm the most important person here.
Yeah.
Alas, there are currently no prospects of me getting doctor in front of my name, but
that's A-okay.
It's okay.
That's but our guest, however, I guess Maya, you should introduce him since it's your friend. Dragged him here.
Yes.
Hopefully,
right,
with his will, not against it.
Alrighty, so our guest today is Amir Bitran, who is a postdoctoral researcher at UC Berkeley, where I am right now, so that's how we met. And he is currently studying protein folding. But another cool fact about Amir is that he's also a very accomplished musician and composer. So we're all very excited and very curious to learn about how he's blending science and the arts together. So welcome, Amir! Woo!
Woo!
Thank you, everybody. Hi, thanks for having me. Such an honor to be on the podcast.
Yay, we are so excited. So I guess for our listeners to get to know you a little bit better, could you tell us a little bit about your background? So I mentioned that you're both a scientist and a musician. Mm-hmm. So how did you become interested in both of those fields?
Yeah. I've been interested in science since I was a little kid. I think a lot of that came from my mom. She's a psychologist, psychology researcher. She has, I think she's the type of person who asks a lot of basic questions. And I think growing up with her, I don't know, was motivated to have this curiosity around the world around me. I was always asking questions since I was a little kid about how this works, how that works. I think I was a little bit annoying about that, but my parents very graciously put up with my many questions. One moment that was actually very pivotal was when I one time visited. I grew up in South Florida, but I had a family visit to San Francisco, and we visited the San Francisco Exploratorium when I was a kid. And yeah, so you guys might know it's a really wonderful science museum that we have here.
It's
And
a
this was
great place.
yeah, it was incredible. This is way back in 2004. And they had an exhibit at the time on the central dogma of biology, on DNA, RNA, and proteins. And I just thought this was like the coolest thing ever. It was like, I don't even remember, but there were all these models and all these just like really clear explanations. And I became so fascinated that, I decided like that very same day, I wanted to buy a book about like how DNA and how proteins work, like one of those Discovery Kids books. So I would say that was one of my very first stints into biology. That was like fifth grade. And to bring things really nicely full circle, I'm actually now back in the San Francisco Bay Area studying exactly this topic. I'm doing research on proteins and a problem called protein folding, which is how they get their molecular shapes that let them function. Just like any machine has a shape, proteins need a specific shape to do all the incredible things they do in our body. And so I'm currently a postdoc here at Cal with Susan Marquesi and Carlos Bustamante, and I'm continuing on a line of work that I actually started in my PhD at Harvard, where I was with Eugene Shaknovich doing biophysics research on a similar problem. And then music, actually, a lot of that comes from my dad. He is a professional violinist, and growing up, he was very adamant that me and my sister should learn music ourselves. So my sister plays the cello, and I played the piano. At first, it was very much an obligation. Even getting me to practice 15 minutes a day was a big uphill battle for my poor parents. I much... apologies.
I know how that feels.
Apologies for my childhood.
I also took piano lessons.
Yeah. So
it was rough on my family as well.
So if my parents are listening, apologies on behalf of my childhood self right now. So I played piano, and eventually I actually came to kind of like it as I grew a little bit older. And one thing that I also really liked was writing my own music. Even since I was a little kid, I would like make these sketches of notes. I had no idea how to read notes when I was a little kid, but I found the process of notation really interesting. So I would just like draw notes on Notepad. And when I was 5, I would like take these sketches to my piano teacher, and they would have like these nonsense names like Machuwoko or something random like that. And then my piano teacher would like very graciously ask me, "Hey Amir, do you want to play Machuwoko today?" And then I would start to play it, and it had like nothing to do with what I had notated. I would play something totally random, and he always was like, so nice about it, and he was like, that sounded so good. And then from there, it was only uphill from there on the composition front. Then maybe I peaked as a kid. I'm not sure. But yeah, exactly. So yeah, as a teenager, I started to write music, more like rock and pop sort of stuff. I really liked recording my own stuff at the time. And then it was really in high school that I realized that notating my music was a very powerful way to get my music out there so that other people could also perform it, including, more accomplished pianists than me, because I tend to write stuff that I usually can't play, or I struggle to play because it's so hard. And then that's how I became more interested in classical music. And yeah, it was really in in college, I majored in both science and music. I was a physics major at Harvard, and then I did a minor in music. So I was frequently taking composition lessons. And at that time, these were two like totally separate passions of mine. It was like a day job and a night job or something like that. And it stayed that way for a while. In fact, I almost found it hard to even imagine how to bring the two together because they felt so different. Music is such an expressive, subjective art form, whereas science is so heavily grounded on logic and intellect. And it was really only during my PhD that I started to discover the possible connections between them. And the way that happened is I was actually working in a lab. I was doing a rotation as I was trying to figure out my lab placement, working with a professor at Harvard and MIT named Leonid Murney. And while in the Murney lab, we got this email from a professor in Paris. Her name is Judith Mina Hattab. She was a postdoc actually at the time. And she's also a pianist. And she had this idea that it would be really cool to put together a concert in Paris where all the pieces are inspired by scientific topics. And she was planning to commission different composers to write music inspired by this. And at the time, she was reaching out to the Murney lab just to get scientific inspiration. She just wanted to know what sort of research the lab was doing, which is on chromatin, is a topic of the Murney lab research. And so we just, originally my PI Leonid was just going to reply with like a little blurb about the research. But then I kind of, at that point, nobody in the lab even knew that I composed. But I kind of volunteered, oh, by the way, I kind of also write music. Maybe I could, be the composer for this particular project. And yeah.
I feel like at that moment, everyone in the lab just kind of turns and looks at you and goes, "What?"
Yeah, exactly. No, it was actually kind of funny because there was somebody in the lab email list who like replied all. I still remember he replied all with this like joking idea for what it would sound like cymbal crash representing this particular protein, crescendos representing these loops, and it was like half joking. But then I was like, yeah, I can actually make this a real thing. And I think they were all like, just what?
What a flex! I love that.
Yeah.
It is such a flex. Honestly, like what like a serendipitous opportunity.
Yeah.
It sounds like the heavens just like opened up and was like, we select you
Yeah.
to do
Yeah.
this.
It's like, and an orchestra or an individual in Paris, nonetheless, which is like famously a hub of the arts since like who knows when. It's like not just like some obscure band, obscure place, an obscure orchestra. It's this is like a very impressive happenstance.
It is, yeah, and
So exciting.
yeah, to date, this has been one of the best performances I've ever received of one of my compositions. You could just tell, I mean, not only, is Paris world-renowned generally hub for art and music, but especially new music, new classical composition has had a very strong presence in Paris. I mean, it's always been at the avant-garde of music. The Impressionists were there, like Debussy, Ravel, and more recently in the later half of the 20th century, a lot of avant-garde musical composition was based in Paris with composers like Pierre Boulez, who were there, Pierre Boulez was there, and so you could just tell that people were used to playing new music, and so the care that they took in learning my piece and the attention to detail, it's one of the few, if not the only time I've received that type of caliber performance. And so it was a real honor that I'm very grateful to have had that opportunity to play with these fantastic musicians from the Radio Philharmonique, the Paris Radio Philharmonic.
Well, it sounds amazing.
Very cool.
And if there is, if you happen to have a recording or a link, we would be happy to share this with our viewers so they could check it out for themselves.
Yes, of course.
And yeah, and if I could interject for maybe our listeners who don't know too much about music, how would you say that classical music is different compared to other genres? Or like what kind of like drew you to composing music in the classical style, I guess?
Yeah, it's a good question. Historically, the truth is, I think they're not as different as they're often made out to be. Classical music, if you want to take like the simplest definition that I can think of, is that classical music is generally speaking music that's notated for other people to play, whereas things like folk or pop music, usually it's more you learn it by ear, or you have like a recording, a definitive recording, and maybe some covers of it. With class, but the thing is, what it is that gets notated is extremely variable, because even if you look back to like the music of Bach, who we consider the quintessential classical composer and who we consider like this very sophisticated type of art, the truth is a lot of his pieces were actually folk dances of his time. Like if you look at his suites, like his French suites or his English suites or his partitas, these pieces that he's written for keyboard as well as for, he's written partitas for violin and cello as well and others. A lot of them are just compilations of folk dances that he's kind of notated and then like riffed off of in a sense. So it's kind of just, so, you could very much imagine somebody taking like hip hop or somebody taking like Taylor Swift or something in the style of Taylor Swift today and like notating it, right? And then just like elaborating on it. And sure enough, contemporary composers are often doing stuff like that. So one of my favorite composers is living composers. Her name is Caroline Shaw, and her music is like hard to pin down because she really does take like vocal singing, and this like she will write songs that where the way they're performed is as if they're a pop song. Basically, she doesn't even sing them with like heavy vibrato or like in a way that you would associate a classical singer. But just by the virtue of the fact that she notates them, it gives a little bit of room for like iterative embellishment in a sense. And and then there are many other composers who will like take influence from all types of like pop music. Like another composer I really like, a living composer, is a Cuban composer named Tania Leon, and she'll take like salsa and like write string quartets based on salsa, right? So it just goes to show how blurred this line kind of is, and how I think the fact that maybe we're a little bit divorced from like we don't really think about minuets today as like a thing people really dance to, right? But like in the 1600s and the 1700s, this might have been like the reggaeton of the day, right, or something like that, or the I don't know whatever that people were or the hip hop like the hip hop of the day, right? And so I think the fact that it is preserved lends itself maybe to a historical separation from the cultural context, and that maybe leads us to think that it's like this really pretentious, sophisticated type of art, but it might not be as removed at least back in the day as we might think it is.
This is very enlightening to me. I had no idea.
I definitely,
but it makes sense the way you say it.
Yeah, I should. My own classical music credentials were getting not quite dragged to Boston Symphony Hall quite a few times in undergrad. I could get cheap tickets through where I was going to school. Mm-hmm. But I will say that like besides the like I go to a concert at a bar down the street from me, I'm wearing one thing, and I'm certainly not going to be wearing that to Symphony Hall. And, like that's maybe the biggest difference for me is what side of my wardrobe I go to.
Yeah.
I will say that like some of these modern classical pieces. And I breathed a sigh of relief when I heard yours, and it did not sound like this. Some modern classical pieces feel like unnecessarily deconstructed, or as I've occasionally described them, like someone dropped a cat on a keyboard and told it to go wild.
Poor cat.
Where it's like I don't know what I'm listening to. One point I got there a little late to Symphony Hall. They had there was some sort of event going on. They had hors d'oeuvres, and we just kind of sat there. Like I tried not to listen too hard and stuffed my face with stuffed grape leaves before the good stuff came on. So kind of full disclosure on my opinions of some modern classical music is it can still seem very pretentious and also not old. So
yeah, I would agree in some cases.
Yeah. And it just kind of there's that weird tension with art where some of it's some art is so as I guess some people just vernacular like for the public that it's frowned upon by people in the art establishment. If someone goes and illicitly paints a building with a really great mural, it's still graffiti, but it might be, the average person might go, that looks really good. And, you know, someone might thumb their nose at it. And then on the other hand, you'll have the folks that I've listened to at Symphony Hall who made these things where I'm like, this doesn't even sound like music. This is someone trying to push what the limit of something is, maybe to impress their peers. I don't know what's happening. And so I think since we're talking about classical music and since we're talking about like that like air of pretension, it does feel like worth saying that like some stuff is just less approachable. And I don't really know why that is.
Yeah. No, 100%. I think, you know, just like with any art form, there can be all sorts of factors that affect how it turns out, including political factors, trends of the time. Yeah, I mean, ultimately, history is going to be the judge, right? Like, there are all these pieces that are out there right now, and the question will be which ones stand the test of time. And I mean, you know, taste evolve, so we can never predict, but I would wager that those pieces that ultimately stand the test of time are going to be the ones that have something that speaks to a general public, right? And pieces that are written with an emphasis on pushing boundaries for its own sake, although they can be very effective at what they're trying to do. I agree with you that it's a fine line between experimentation, but then, you know, doing an experiment just for its own right, and then you lose the sort of dramatic arc that makes an effective piece, or the hook that engages an audience effectively. So yeah, you know, and it happens to me with some music as well, with some contemporary music. I mean, to some extent, it is an acquired taste. Like, there are some pieces that the first few times I heard them, I was just like, what is this? Like, it was just like all these, you know, I don't know, just very jarring. But then the more I listened and kind of got used to the musical language, the more I came to appreciate different aspects of it. Like, I would say, for example, 12-tone music. It's, you know, during the early 20th century, there was the rise of what's called 12-tone music, where, you know, traditionally you have what's called your tonal center or your key, right? Like, you can say, oh, this song is in C major or in D major or whatever. And in 12-tone music, the idea was to try and completely eliminate any semblance of key and just sort of have the music float ethereally between different keys. And like, when you first listen to it, if you're not used to it, it just sounds really wild. But then the more I came to hear it, I came to find that there are a lot of colors you can create with these non-tonal harmonies. And now it's actually a type of music that I really appreciate. So to some extent, it is, I think, an acquired taste. But then there are also pieces where I would totally agree. And I feel like they're written for technique first instead of some sort of creative end in mind.
So speaking of, like, I guess the creative end, you know, kind of getting back to you and your work, like, what is science-inspired music, right? You were talking about, like, you're making something, you're talking about chromatin, which, you know, for those listeners who may be less familiar with DNA, that's, maybe you want to get into, like, what that is, what you were being inspired by, but also, like, what is your process for making that in a way that still creates, you know, an actual coherent piece of music? You know, I think that's a challenging concept.
It is, and it's honestly part of the reason why I was a little bit hesitant to try writing science-inspired music when I was in college, before I got this opportunity. It's because I was worried how to do it without sounding prosaic, right? How to do it without having it feel like, oh, this chord here corresponds in a one-to-one way with, like, this particular protein, right? I don't know. I think that's boring. Maybe some composer can convince me otherwise. But I think that the way that I instead go about it is I'll take the idea that, and I'll try to sort of find what is the essence behind it that I find somehow aesthetically pleasing. You can even say beautiful. And that's a word that scientists will use too, right? Like, they'll see data and they'll say, oh, this is beautiful data, because it kind of tells a story, right? And so, for example, for the piece you were mentioning about chromatin, so, chromatin is basically, you have DNA. DNA has the instructions that make up all of us and that make all the proteins in our body, right? It's kind of the hereditary material. But DNA is not just information. It's also a physical material, right? It's a double helix. And because it's a physical material, it needs to be fit in a space, which is the nucleus of our cells, right? And so chromatin is actually what happens to DNA when it is actually kind of compacted into a material. The DNA gets wrapped around these proteins called histones, which are a sort of packaging unit. And it's a way of basically creating this fibrous material out of DNA. And the shape of the chromatin is very important because we have many cells in our body, and the cells are all different, right? We have skin cells, we have hair cells, we have neurons, and they actually all have the exact same DNA as one another, and yet they act totally differently, right? And one of the main reasons that they act so differently is because different parts of the DNA are literally more accessible, physically accessible in space to be quote unquote read. Right. And so how you package the DNA really matters in terms of allowing certain genes to be turned on or off, and which ones are on or off then dictates how the cell acts and what the cell looks like. And so, this is a very interesting area of research that's still, there are a lot of, even to this day, a lot of open questions in that particular field. And so the lab that I was in at the time, the Murney lab, was kind of trying to understand what might be the mechanism by which chromatin sort of gets organized. And this is at an even larger scale. So I was talking about wrapping DNA around these histone proteins. And then what you'll do is you'll take these DNA wrapped around histones, which are like beads on a string, and then like organize it on an even larger scale. So if you ask like how long is that scale, it's like 1 million, on the order of like 1 million base pairs long, like base pairs, being the letters of DNA. And basically they were trying to understand how at that larger scale DNA is organized, and that scale is kind of the one that really matters for accessibility of long regions of DNA, whether those genes are on or off. And they came up with this model where you have these proteins that kind of make loops out of DNA, and when they make these loops, they can bring together distant segments of the DNA. For instance, you have regions called enhancers and promoters, which need to be brought close in space. And these two types of regions are important because when they're brought together, it actually then lets a gene that's nearby to these regions actually get turned on. It brings all the machinery needed to read the information in that gene. And so forming of these types of loops is very important for compaction of DNA and for bringing together regions that need to talk to each other. And so they proposed a mechanism. At first, it was just proposed theoretically, but more recently, there's actually been very exciting experimental evidence of that mechanism as well. And so, how do you take that and turn it into music? Well, for me, it was the fact that there's this very small scale process, right? It's sort of, you look at these little molecules and then you can really zoom in and watch how with sophisticated enough microscopes, you could watch how proteins make loops out of DNA. The loops can grow and shrink. But then if you take a couple steps back and zoom out, you see that the DNA as a whole, the chromatin as a whole, has this really cool macroscopic behavior, like condensation into chromosomes, like the ones that you can see like on these pictures of like the different chromosomes. And so the idea that small scale behavior can lead to like big effects was, to me, just something really cool. And I would say that is what I was trying to capture in that piece. It was less about a one-to-one relationship, like, oh, this is this protein, and then this chord is the histones or whatever. It was more like that idea of going from like something small to something really big and zooming out. And that just, to me, was something that felt like it could lend itself to music because it is a little bit more visceral. It's a little bit more something dynamic. Like you could even imagine, loops growing and shrinking. That's, even as an idea, that's something that has motion to it. It has dynamicity, right? And so that was kind of my starting point for how I wrote the piece. And then, I found a musical motif that is actually inspired by that idea, and then kind of let the piece unfurl from there.
I feel like it goes back to the idea that you mentioned earlier about classical music being like this opportunity to embellish upon and like build upon like what you have. It sounds like it's kind of like an iterative process. So I thought that's really cool. It's like you can just keep adding and adding, and it keeps growing and changing.
Exactly, exactly. Yeah, that's definitely something that as a composer, you know, you you go back to many times. Like the way I will compose is I might have a melody or a motif, right? A set of notes. And often when I'm composing, I will lay that out first, and then I'll kind of go back to it and I'll say, okay, maybe instead of just having one instrument play it, I can split it into two different instruments, or I can add like a little percussive hit like at this particular moment. So you definitely kind of go back to a piece and revise it. And then by paying attention to those details, that to me is what brings a piece to life and what makes it engaging to a listener, not just sort of this abstract musical idea, but something that a listener will listen to and be like, oh, wow, I really like how that sounds.
Awesome. And I think as a special treat for this episode, Amir has agreed to walk us through some segments of When DNA Makes Loops so that both we and listeners can understand what's happening musically. All right, listeners, we're going to start from the beginning of When DNA Makes Loops. How does everybody feel after the first segment of When DNA Makes Loops?
I feel kind of loopy, gonna be honest. No, I definitely heard like like kind of like the little like that like it to me like that little like piano like that motif of like the like it made me really feel like I was like on a roller coaster doing a little loop almost.
Yeah,
I felt like a lot of tension. Like I felt like very coiled. Like I'm just thinking about like DNA Makes Loops. Like the words are just coming to me now, but I felt like very like a lot of tension. Maybe a little stressed, but yeah.
To me, it felt very like chaotic to start with the violins all kind of coming in and like coming together, kind of like it starts almost like an orchestra warming up, which was interesting to me. Like it gave me a little bit of
walk
that
us
vibe.
through. Yeah.
Yeah.
Walk us through, Amir. What was going through the brain as you composed this?
Yeah. So what we heard here is the main musical figure or the main motif in this piece, which I don't want to overinterpret. I think one thing I want to preface by saying is that I don't think there is a single right or wrong interpretation of music I write. I really like when different people have their own opinions, and so I don't want to sound as if my interpretation is by any means the definitive explanation. All I'm going to tell you is how I was thinking about it when I wrote it, which is this first motif, which came towards like the second half of what we just listened to, is the loop formation motif. And so, this is supposed to be the sort of microscopic building block of this whole piece. And kind of what happens as the piece goes on is this idea repeats itself, and it repeats itself in more and more instruments, and it incorporates itself into larger musical textures, which to me is sort of how I was trying to capture that idea of small, events at a very small length scale can manifest in behavior of much larger length scales, right? And so here at the beginning of the piece, I was introducing what's going on at those very smallest length scales, right? Which scientifically corresponds to a protein that's making loops that grow and shrink out of DNA, right? And if you look at proteins, they're really, really tiny. I mean, they're, as far as molecules go, they're large, but compared to the sorts of things we're used to thinking about, they're very small. And they're not that much bigger than the water molecules that are all around them, right? So if you were to make a movie of how a protein behaves, it's not like a car that always goes forward, right? It's more like one of those very old manual transmission cars that I would have no idea how to drive. But like it will like start and then it'll like stutter and then like I don't know, maybe even go back a little bit.
What are you talking about?
Yeah, okay, I don't know how a manual works, but like maybe like but you get the idea. And so I tried to capture that a little bit in the fact that, we have that viola that plays that first melody, right? The first motif. And you might notice it didn't go straight into it. It sort of like tried a couple times and failed. It played these little excerpts. And then eventually those little excerpts blossomed into the full motif, right? Which you can think of it as like this molecular motor stuttering a little bit at first and then kind of finally going forward. And so... yeah.
Sorry, I think I see what you're talking about with the car thing. I think you're thinking about like a hand crank.
Yeah.
Or more than the manual, like where it's stutters like starting a lawnmower, sort of like where you try a few times before it goes.
I don't know. I have this image from movies that like manual cars like don't start very effectively, but I actually have no idea what I'm talking about.
Yeah, they're always like super loud and they're like
yeah.
You're talking about like a model
has to like
old,
like Mickey Mouse, like old.
Yeah.
I was gonna say,
Okay, maybe I'm judging manual cars in too broad of strokes. I've never driven one.
I know. There's plenty of manual, just not in the U.S. particularly, but I mean in Europe, for example, there's plenty of. There's definitely listeners who'd be listening to that and go, "Oh my God, what is going on here?"
But I see what you're saying. I feel like the kind of like stuttering, the like random movement.
Yeah.
It's like I feel like the first segment that we listened to is very evocative of that.
To be clear, I was roasting the analogy, but as someone who's seen like protein motion before and has studied this sort of thing before, the musical motif makes perfect sense to me. I'm trying to think of a better way of like depicting that because it's such a things at that scale don't behave. It's almost like watching like a small animal like being buffeted by the waves, like a small sea creature being buffeted by the waves or something, where like you're having this environment that's really messing with it.
Yeah, actually, an analogy that I'll often use when I'm like teaching like younger students is it's as if biology is happening in a Category 5 hurricane, right? So you could maybe like a better analogy would be like waves, like if you have like a cruise ship that's trying to sail through like a Category 5 hurricane, or even like a motorboat, right? It's not gonna like go forward in a particularly linear way. It'll go back and forth, it'll rock a lot. So it's maybe something like that.
Yeah,
you guys are so right. Yeah, the cell is a crazy place to be in.
It really is.
It's really worth watching that. I know, like listeners, if you're like hearing about this concept for the first time, like to like pull up. There was at least this is probably pretty dated now, but the inner life of the cell animation.
Oh, yeah.
You can look at like molecular dynamic simulations. The inner life of the cell is just gorgeous.
It's a wonderful. I was fortunate enough to have my first ever college biology class taught by the late Rob Liu, who was one of the creators of this anime.
Oh my gosh, Rob! I met Rob as well. He was a cool dude.
He's amazing. He was amazing.
Yeah. Sam. Rob was one of the guys who, like, I don't know if you ever met him. Did you ever meet him? He was one of the guys who kind of like helped facilitate the beginning of Harvard Life Science Outreach.
Interesting.
Which
I owe a lot to this man then.
Yeah, you and I both. For important context, both Sam and I got at least a part of our start in like the life sciences through a internship at a like kind of this life science outreach teaching place working under this woman named Alia, who I would love to have on the podcast one day.
Yeah.
Like that would be cool. But like one of her mentors was this guy named Rob Liu, who made this video, who, like, for most biology students, like, they have seen this video, and like everyone has seen this video.
It is one of the more beautiful videos out there, period.
Yeah.
Like, regardless of
Yeah.
subject matter. It's really well done. It's gorgeous. And maybe thinking about this piece, to have that be something that you're aware of would make this make a lot more sense the way we're talking about it.
Yeah.
But there's a huge visual component to this, despite that we're talking about an audio medium. We're in an audio medium talking about an audio piece.
Yeah. But I think for our listeners, we'll certainly be able to include the video in the description as well.
Yes, we should totally put that in the description.
So,
But so analogies aside, I could see that, like, where you're coming from with that, and I think it's very effective in the start of the piece. Yeah.
That was very beautiful. I liked that.
That was very dramatic.
Yeah, I was gonna say, that drum that comes in there?
Yeah, the bass drum.
Gaboom.
Yeah.
Yeah. Also, was there oboe going on there? I thought I heard some oboe.
There was
or
no
maybe it was
oboe in this
clarinet.
piece. It was a clarinet. Yeah, there was a clarinet.
Yeah.
Yeah, there's like that huge tonal shift from like something that's chaotic to something grander, and it's interesting, like, hear that build through that just section of the piece.
Yeah, a lot of this piece, up until before that moment, was very chromatic, which means, so if you're looking at the piano, you'll normally have, like, your notes that are part of your key, like C major, D major, like we were talking about before, right? But up until before that moment, I was sort of playing a lot of pitches that are between the ones that you would expect to be in your main key, and that creates a lot of musical tension. And then suddenly, at that moment of around 1 minute and 8 seconds, we reach the key of E flat major, and we're sort of solidly there. And I think that's part of, and we sort of hang out there for a little while, and I think that's part of what creates that feeling of resolution.
Oh, interesting. Yeah.
That makes sense. Yeah, because it did feel like it was like something bigger than us was happening in that segment. I completely agree with you, how, like you said, like it's kind of the theme of, like, zooming out from, like, these, like, smaller, like, more chaotic things that are happening. And I think we had this conversation before, but I remember you saying that, like, drama is also an important part of composing classical music as well, and I certainly felt the drama here.
Yeah, and I think sort of what you were talking about before, Sam, about music that doesn't feel like it goes anywhere, where maybe it can be experimental and maybe it can try a lot of new techniques, but it's not as appealing to a listener. A lot of that has to do with drama, right? I think a really appealing piece will be one where we always feel like it's going anywhere, or maybe sometimes it doesn't go anywhere, but the very virtue of it not going anywhere is a decision, right? And it's itself part of the drama, right? And so this is something that I think is that I think a lot about in my writing, how at all scales, time scales, both within a given motif or within a given melody, and then on the scale of how the piece as a whole is built, which is more on the minute scale, trying to create different types of narrative arc. And I think in science, it's also extremely important, right? If you want to put together, if you make, usually a discovery that we consider like a high impact discovery will be one that is dramatic somehow, right? It sort of goes against our expectation, or it tells some sort of story with a beginning, middle, and end. And it's definitely something we think about as scientists when we are writing papers, giving talks. And so I think that's something that they really have in common.
Yeah, and I think that's an interesting thing for the listeners to hear too, because, like, as someone who's been in academia, who's experienced science, and all four of us have, like, the fact that there is a narrative arc to a paper, there's a narrative arc to a research grant application to like how we give presentations to other scientists, how like you set up this like your expectation, you set up kind of your background. It's like the what is it, the exposition of a story, and then you give this the kind of the narrative arc, and then you either confirm or subvert an expectation, and then you have a conclusion. Like that is how you put together a scientific presentation or a paper. And I suppose it's also how you put together a piece of classical music, which is
Pretty
it's
cool.
kind of fascinating. I don't know if that it's just kind of a human thing. I think we just do. It's just very, very cool.
The parallels are paralleling.
Yeah.
It's very interesting, and it's very I guess I had never put the two next to each other like that, so this is like really cool to see.
Yeah, I
In
think
the
it's
end, we are all just people wanting to tell our little stories.
exactly. Exactly. Yeah.
Oh my. Listeners, I wish you could see, but Joe had like the funniest reaction to the end of this segment. Your eyes got really big and you were like, oh. Oh.
Surprise.
Surprise. Yeah, to me, I did feel the surprise in this. It kind of felt like it was very reminiscent of like a horror movie a little bit. Like it's very like quiet. You feel like something is building, but you're like not quite sure like when it's gonna happen. So we're just like waiting for it to happen, and it happens.
Yeah. A lot of suspense.
Yeah. Yeah. Being a protein in the inside of a cell is very much like constantly experiencing a horror movie.
Terrifying.
You can always be hit by something.
Like,
I don't
never
know.
know what's gonna happen.
Yeah.
Yeah.
I mean, this part of the piece, sort of scientifically, it was inspired by a different mechanism of organizing DNA, which is the first type of mechanism is a more active mechanism where you have these protein motors that are constantly like making these loops out of DNA. But in addition, it turns out that there are some more passive forces that are akin to gravity, where different parts of chromatin will attract each other or repel each other, and that this can also be a very important way of making sure different parts get compacted or don't get compacted. And so what we heard was kind of the transition from this more busy part into these more sparse parts, where you have these psi-like motifs or these descending motifs. And, I feel like things that descend are ubiquitous in classical music, and I think just melodies and music more generally. I think that sort of feeling of descending, melodic descent is often evokes gravity, and I think maybe that's part of one reason why people might be drawn to it as a sound. And here I use it as well in order to evoke these sorts of more passive forces that organize DNA. And more generally, as a piece, when you're thinking about a larger scale structure in a work like this, you'll generally want to incorporate sonic contrast, right? And this section served as a relief from the very dense material we had before, where pretty much all the instruments were playing all the time. You had material basically in all registers from very low pitches to very high pitches and a lot of motion. And then here I wanted to purposely create something a little bit more sparse as a contrast. And so this section kind of continues beyond that stopping point that we stopped at just now, but that gives you a little bit of a taste of how using string harmonics, which are these sorts of thinner sounds, which are often actually used in horror movies. It's not actually something I was thinking about, but it is a good point that I should mention it. No, I get it. That's what's awesome about music, right? Is that you can interpret it in all sorts of ways. But it is, you're right, that actually oftentimes when you're trying to create a lot of suspense, the orchestra will play string harmonics, which is what I was using there. And yeah, that's how I want to.
It's very valuable. Yeah, it's so valuable to have us also hear your interpretation too, because I feel like we're learning so much about
this is
what goes
really...
behind making this song. It's so cool.
Yeah, agreed.
And I feel like I'm learning how the choices I make are perceived in so many diverse ways, which I really like as well. So yeah,
sure.
I'm just like, Amir, I'm scared.
I was like, what part of a cell is this scary? It's like
all of it.
The proteus.
Definitely, the lysosome, right? You can get degraded any second, or or Maia, your proteasome. It's it's like a giant monster. Yeah, giant.
It's coming to get you.
Yeah. Exactly.
I worked on unfoldaces, so okay. I don't know if it's
terrifying.
Yeah. That's a sorry. There's things in the cell that destroy things. This is good, actually. You need this.
Exactly.
So it's scary if you are a protein in the cell, I suppose, from the perspective of a person who likes to remain alive. Very important.
Yeah, exactly.
So this music being from the perspective of a part of a cell is a very different perspective than I, a person with lots of cells that is alive, have on the
That's right.
the interior of myself.
But hey, that's the nice thing about different length scales, right? You see it differently.
Yeah.
Yeah, but I feel like I'm really gaining such an appreciation that I wouldn't have had before on molecular processes such as DNA looping with this.
Yeah, this is a fascinating experience talking about this piece like this. Yeah,
I know it's such a rare and amazing opportunity. So
yeah, this is wild. All right, so just for the listeners, we're gonna skip to the end of the piece now. So let's see what awaits us there.
Bravo!
Yeah, I think I'm kind of struck by... So I was talking... some other folks have been getting into making music recently too, but... something was playing, something else was playing.
Oh, sorry. Yeah, something was auto-playing.
Yeah. But I was going to say, it's I think that there's this is not my original idea, but there's kind of a difference between a soundtrack and music. I think a lot of us are used to listening to more classical music in the context of something else, like in a movie or and like the beginning of this section to me is like, part of me is like, is this supposed to be like a peaceful scene or a dramatic one? I'm like, no, that's not what's happening here. That's not what this is. This isn't the soundtrack. Like, that's kind of like what jumped in my head. I was like, that's not a way to process this. Or it could be, but it doesn't make sense. It's not working. So that's kind of where I was at. It was very, very interesting, the drama, but also that like more peaceful, probably, if I were to make a guess, like actually on the scale melodies happening there. Is that like what I'm hearing? Am I understanding what's going on a little bit more? Or
Yeah, this section is a chorale, as it's called. So what's happening? Well, it's a bit an embellished chorale. So when a chorale is, as it sounds like, it's something inspired by choir music in which all the parts, all the different instruments in this case, are playing homophonically, meaning at the same time, but different notes in such a way that you get these large chords. And it has this sort of block-like texture, and I then embellished it. I added the clarinet and sometimes the violin, embellishing it a little bit as well by playing like little melodies on top of it. But that those block chords are kind of the main idea. And so they are meant to sort of be a majestic ending to the piece. The image I had in mind, which of course is just one way to interpret it, is that this is sort of, we're not really looking at the very, very small scale anymore, but we're now actually looking at whole chromosomes, right? So it's like we've zoomed out to see the entire cell nucleus. I mean, which, to be fair, is still very small scale compared to what we're used to thinking about, but not like molecule, like small scale. It's like the type of scale that you can now see on a regular light microscope. You don't need like an electron microscope to see it. So it's like we've zoomed out into these whole, large scale structures that might appear, for instance, before a cell is about to divide. And we're sort of concluding the journey of how you go from crazy, chaotic molecular underpinnings where molecules are always colliding with each other and doing all this crazy stuff, to this much larger scale where things actually behave themselves. And we're marveling at the fact that that is even possible, that you can get order from chaos in a sense. And so that's sort of the interpretation I had of that ending.
Yeah, super interesting. I can be honest, it made me think of cytokinesis, which for our listeners, like that's kind of the moment when a cell that is dividing like fully splits into two cells. And like with a kind of like the drum at the very end, I just got this image of like the bloop, like how it like just like splits apart. But obviously, like that's obviously like anyone can interpret music at like the way they would like. Sounds like the way I was thinking about it was maybe a scale up from what you were thinking about it per se.
But I like that. I think it's generally reflecting, yes, something big and just a process that we can maybe, some sort of emergent process that's functional and that's predictable and orderly, right? Like cytokinesis or just even the condensation of chromosomes. It's just, there can be all sorts of, images that might fit into that. And I think that's totally a fair one as well. Yeah.
No.
Yeah, for me, I was basking in the majesty, and I like the way you like explained it like in musical terms, because I was like, oh, like how can you use music to kind of like evoke that like something is bigger than yourself, or like it's like so like grand and like on a larger scale, like you're saying. So I definitely, for me, that came across like very well in this last section, and I also separately, like the vision I had was certainly like not on the cellular level, but like it was like kind of like like a hero's journey that's ending, kind of like going back to like the start or like his homeland or whatever. Like that was kind of like the image that was being painted in my head too.
Yeah.
So I was like, oh,
Yeah.
wow, this is like, it's so cool. So
Yeah.
but it's still like a similar story. Yeah.
The chromosomal Hercules or something like that.
Yeah.
Yeah, no, I love that. I mean, I really want, for me, these scientific concepts are a starting point, and an inspiration point. But I am really only drawn to concepts where I feel like they contain within them something that is, you know, aesthetically pleasing and aesthetically compelling to anybody, right? I don't want it to be the case that somebody needs to know the scientific context in order to enjoy the work. My hope is that somebody, even though, this piece was premiered in a special concert slash lecture event where every piece was preceded by a 5-minute lecture to a general audience about the topic that inspired it. And so people did have that context. But my hope is that if you took the same piece and then performed it at any chamber concert without even giving people context, I'm hoping that people will get something out of it without even having any idea what it's about. And so I'm happy to hear that even just you're able to bask in the sounds themselves and the contour of the piece itself.
Yeah. I mean, it's interesting you bring up like the context and being able to enjoy it without context, and how, I think that's true of a lot of music, right? People come into these things with context. I was thinking very particular. I forget the composer's name. The Enigma Variations. That's
Elgar, yeah.
Yeah. How that those pieces have been used in movies and all sorts of other things. But at the end of the day, it was, if I remember correctly, it was primarily the composer was writing about things in his own life. Which, is fascinating when I think it's the piece, if I remember correctly, it's a piece used at the end of the movie Dunkirk. But it's interesting because that was not what that piece was composed for. And so how he kind of runs through and uses, it has all of its own, it has a life of its own and interpretation of its own, even when you don't have that context to it. Yeah.
Exactly.
Yeah, I think that's the great part about music, is that it can be accessible regardless of your background, like you're saying. So, and it's open to many interpretations as well, which is also something we try to encourage in the science world as well, right?
Yeah.
To have a lot of different perspectives and viewpoints on different pieces of data, et cetera, et cetera. But
yeah.
I think it's really amazing to use music kind of as this way to kind of subtly introduce people to different scientific concepts, or kind of show them this is how you've kind of imagined them, but it also just is a standalone thing that anybody can enjoy, which is also in itself I think amazing too.
Right Yeah, it can work on multiple ways. It can work as a vehicle to help communicate science, right? I think that a scientist, we sometimes have a hard time distilling these very abstract things we study into terms and concepts that are accessible to a more general audience. And I think art in general really helps with that. I mean, that's one of the things that's so masterful about The Inner Life of the Cell, Rob Lu's video, is that it makes it so vivid. And yeah, as you guys were saying, it's just aesthetically so well made, and so a viewer will just watch it and just be like, wow, that is so beautiful. And that is kind of you can say, an emotional way of drawing people into the getting them invested in the topic, right? And they show it in so many biology classes, I think, for a good reason. And music can be another way of doing this, right? It's sort of taking this concept that's abstract, but then converting it into a vehicle that is, all cultures around the world have, right? And that everybody can appreciate. And at the same time, it can be a work of art on its own right. It doesn't have to be linked to the science. And that's why one of my hopes is that it stands alone even without that scientific background. But that's a challenging thing to do, and it's something that I am always striving to do, and trying to work on with each piece I write.
Nice. And I think, maybe a dream collaboration, and maybe if one day I can figure out molecular simulations, would be to have like a visualizer with like some of your pieces. I'm imagining that could be a way to, I don't know, bring it to another level. But
cool.
Or you can make cover art for one of my pieces. That would also be really cool. But yeah, I love that. I love that idea. Yeah.
Yes.
Important.
It will happen for this episode.
Awesome.
Important context for listeners who may not be aware. Maia is our resident artist, who makes all
Very
our
talented.
beautiful cover art.
Yeah. Thank you.
Yeah. If you didn't know where that cover art came from, it's Maia. So this is
yay, Maia.
Sorry,
no
Dr.
surprise
Maia,
that Maia.
no surprise that Dr. Maia dragged another artist on this podcast.
There was an enrichment for Dr. Artists on this podcast. On this call right now. But what a great opportunity to have you on the show, Amir. And I think like we were saying earlier, the test of time will prove if 500 years from now your music will maybe inspire students from everywhere, science students, music students, wherever they are.
I will say,
I hope it's a great source of inspiration for them.
I will say, like, I am probably going to be listening to this. Like, I'm starting to do some work on, like, DNA replication and DNA repair and things like that, and this music could fit in well when I'm like doing my assays to measure that kind of stuff.
As background music, keep you motivated. Like,
I think it also like it brings a little wonder back to the science, like as compared to having it be like, oh, this is a thing I have done for 10 years and I do the same thing over and over again and it's boring, but like, oh, it's actually kind of cool and pretty and
it brings a lot of like joy back into I think science for us, at least to like hear about it this way.
I'm really glad to hear that.
That's thank you.
One of my goals.
No, I mean, well, thank you. Yes.
Yeah.
But it's been a real treat to have you on the show, Amir. And I guess one last question before we close out this episode is, what are you up to now musically? What are you working on? What can we look forward to from you?
Yes. So on the pipeline, I just recently finished writing a song that is not particularly science inspired, although it's actually, I mean, there are definitely tinges of natural imagery in it. And so it was a song written by a very talented, or the text was written by a very talented poet friend of mine named Charlotte Wang. And she very kindly let me use one of her poems and set it to music. And my current singing group, my a cappella group, is now in the process of learning the song. And so we're going to perform it in the next few months, which I'm very excited for.
That's cool.
That's so cool.
And on the more, science or nature inspired side, I have started to write a piece for cello and piano that was inspired by Bryce Canyon, the Bryce Canyon National Park, which I took a hiking trip to a year ago. And the trail we hiked on was called Fairyland Trail. And I just thought that was such a beautiful name for it, because if you know about Bryce Canyon, it has these really beautiful geologic structures called hoodoos, which are these pillars that formed as a result of repeated freeze-thaw cycles of the ice, leading to weathering and these really impressive pillars. And it really looks like some sort of castle out of a fairy tale or something like that. And so, and it's all this beautiful, rust-colored reddish rock that's so typical of the Southwest deserts, Utah and elsewhere. And so as I was walking through it, it really felt so magical, and it almost instantly I started to hear harmonies that fit well. And so I'm trying to set that to music now.
Cool.
And so that's maybe less about molecular biology, but more geological processes and geological landscapes that are inspiring that work.
That rocks.
Fascinating. That rocks.
Nice.
We couldn't get through another episode without
It's never been our goal, Maya.
I thought maybe this episode would be different.
Nope.
That does indeed rock, though. And we are so excited to hear it once it drops. Alrighty, so with that, thank you for listening. Thank you, Amir, for coming on the show and teaching us so much about science-inspired music. We can't wait to hear more from you.
Thank you, guys. This was such a fun conversation, and it was a delight for me to be on the podcast.